In this video, we have a polynomial function that is of degree 4. We are also told that these are two of the factors of the function, and we need to find all of the zeros and all of the intercepts. Alright, so as we've talked about finding zeros of polynomial functions, we look at the degree. So a degree of 4 means I should have 4 solutions, 4 zeros, right? By knowing two factors already, I can do synthetic division. If I use x plus 4, I'll be left with a polynomial of degree 3. Once I do synthetic division on this leftover guy with x minus 1, I'll be left with a polynomial of degree 2. And we know that once we can get down to a degree of 2, that means it's quadratic, and we have all kinds of methods for solving quadratic equations. So let's start there, and let's try to do synthetic division and break this guy down so that we can find all of the zeros and all of the intercepts. Alright, so let's go ahead and get started here. I'm going to use the x plus 4 factor first. If you want to use x minus 1 first, it doesn't really matter. It's all going to be the same. The only thing that's going to be different is going to be the polynomial that you have in the middle. So if you do x minus 1 and I do x plus 4, the result right here in the middle is going to be different. But once you do it for the second part of the synthetic division, we're going to have the same thing. Alright, so my headings k, this is x to the 4, 3, 2, 1, and my constant. So if I start with x plus 4, that means my k value that I'll use is negative 4. I have 1x to the 4th, minus 1x to the 3rd, minus 4x squared, plus 52x minus 48. Now, if we are doing everything correctly, as long as you don't mess up and I don't mess up, then we know that this is supposed to be a remainder of 0. In fact, when I was scratching this out earlier, I got a little careless, and I realized I'm not going to get a 0 here. So where did I make my mistake? And it was just simple arithmetic. I was thinking of something else. I was distracted. But I knew what I was supposed to have. And so when things didn't check out, I went back and I figured out what went wrong. I didn't just assume that things were right when they clearly were not. So first things first is we bring down the 1. And we go through that process of multiplying and adding. So multiply times negative 4, we get negative 4. Combine, and we get negative 5. Multiply times negative 4, we get 20. Add these guys, and that's positive 16. Then negative 4 times 16 is negative 64. These guys combine to give me a negative 12. Multiply times negative 4 for the final time, we get positive 48. And there is my remainder of 0. That's what we're supposed to have, and everything checks out. Now, we've gone from x to the 4th to this guy's x to the 3rd. So we're going to do synthetic division another time. And our synthetic division doesn't need to be as long because we've already cut out one degree. So I can stop right there. So in this case, I'm going to use the x minus 1, which means my k value is positive 1. All right? So we'll bring down the 1. And now we're going to multiply times k to get 1. Combine these guys to get negative 4. Times 1 is still negative 1. These guys combine to give me 12. Multiply times 1 for the final time, that's 12. And we have a remainder of 0. Again, we knew we were supposed to have that, so we're on the right track. Once we get down to the end result, we've gone from x to the 4th, x to the 3rd. We divided a second time, so that makes this guy x squared. We can now use that to write our equation that we need to solve. So that means we need to solve x squared minus 4x plus 12 is equal to 0. We need to solve this guy in order to find the two remaining solutions. We already know two of the answers. We know that negative 4 and positive 1 are two of our zeros. We just have to find the other two. All right, so we need to solve this. Let's go through our progression. can I solve this by factoring? No. Square root property we know is already out. Completing the square. Well, this is understood to be a 1 right here. This is a 4, that's even, so yeah, this is great for completing the square. Alright, so to complete the square, we know that first we want to move the 12 to the other side, so make that negative 12. We know that we're going to be doing some manipulating so that the left side becomes a square. Well, to figure out what goes in there, remember we take half of 4. Half of 4, or negative 4, is negative 2. And when we square that, that's what goes into the gap. So you divide by 2 to get negative 2. You square to get positive 4. But if I add 4 on the left side of the equation, I have to balance things and add 4 to the right side as well. And so now we have x minus 2 quantity squared is equal to negative 8. And as we've done, completing the square sets you up to use the square root property. So we take the square root of both sides. Don't forget the plus or minus. Also, when you think about negative 8, or really 8, because we know what the negative is going to do, we want to see if there's a way that we can factor that so that there's a perfect square for a factor. And 8 breaks down as 4 times 2. So between these two guys, there is some simplifying here. So x minus 2 is equal to plus or minus. The square root of 4 is 2. The negative factor inside comes out as an I. And the square root of 2 cannot simplify anymore, so it stays as the square root of 2. And finish getting x by itself by moving the 2 to the other side. So that's positive 2. And the plus or minus stays with the 2i square roots of 2. Now don't box this yet. We have to make sure that we answer the question. The question here says find all zeros. Okay, so the zeros, well, they already gave you 2 zeros because they gave you 2 factors. And those 2 factors corresponded to these k values that we have of negative 4 and 1. So those are your first 2 zeros. So negative 4 and 1. And then we solved the resulting quadratic equation that came out from this synthetic division. We converted this to a quadratic equation, we solved it, and we have 2 plus or minus 2i square roots of 2. So in terms of finding the zeros, done. And now we want to make sure that we list all of the intercepts. Okay, so as we mentioned in the notes, the only x-intercepts that you're going to have are going to be those that are connected to the real zeros. See, negative 4 and 1 are real. These guys are imaginary, so these imaginary guys are never going to contribute to x-intercepts. So we end up with just negative 4 comma 0, and then we have 1 comma 0. These guys are imaginary. They do not give us x-intercepts. Don't try it. But when we are asked to find all intercepts, that also means the y-intercept. And we know that for every y-intercept, x is 0. And when you look back at the original problem here, if you plug in 0 for all these guys, the only thing that's left is negative 48. So there you go. All of the zeros and all of the intercepts, including both the x and the y-intercepts, for this polynomial function.